Okay, so we will be discussing about Matplotlib library and some of the visualizations in Python, because whenever you are doing a particular problem, when you're solving a problem, you like to graph it and see the trends and try to analyze the problem in a graphical way. That will help us a lot. Also, nowadays in data science, Python is used the most to solve problems. The basic library for visualization in Python is Matplotlib. Just rerun. Wait, just use some more plain text. Okay, so we'll be discussing about Matplotlib, and then we'll discuss about how to plot something from a text file, like plotting data from file, which is most important for many of you guys who are working on. Oh, reload this page. So this will be important for people who are working on various problems where you have to import certain data which you get from some experiment or some, let's say, from a database. Like if you're working on some astronomy projects, then you need to get data from, let's say, SDSS or some Spitzer telescope or something. So you need to visualize the data, and for that you have to invoke the data in your Python file and then work with. So I am using Jupyter notebooks for the tutorial. It will be good if you can uh, use a Jupyter notebook by your side and run this command while I teach, or you can download them later. It will be there in the repository, so you can check them out later as well. Okay. So like last time we saw how the commands for importing, which was this. Um, So these were the commands for importing. So for importing a particular library, you use this command import that particular library and a keyword and a identifier like np. So whenever I write np dot something, that means I am invoking the function from the library numpy. Okay. So here I am using both the libraries NumPy and Matplotlib. So if you notice Matplotlib, I am using a particular section of Matplotlib called PyPlot. Matplotlib has a lot of sections. So to know more about Matplotlib section, it's always good to check the documentation. Just go to Matplotlib's documentation, and you can see the various parts of Matplotlib. Like just randomly select, for example, this particular plot. So if you go to, so there are a lot of examples in Matplotlib itself which you can work out by yourself. So this is one of the library, matplotlib.pyplot, and this is one of the function called plot, which will be used the most because it is used for plotting stuff. So this is the matplotlib plot pyplot. It has a lot of functions like this. Right. Similar to pyplot, there is something called as animation, matplotlib.animation, which is for animation, and so you can see the kind of modules. So these are all your modules. So one of them is animation. There is something called as markers, matplotlib lines. There are a lot of stuff. So we'll come to few of them later in the tutorial. But the major one is matplotlib.pyplot, which I am calling it as PLT. So wherever in the program I use the word PLT, that means I'm referring to the particular module on Matplotlib. Okay. Uh, so this is used to actually display the Matplotlib figure in the notebook. If you're writing a Python code separately in a text file and then running in your computer, then you don't need them. I'm using this because I want to display the figure in my notebook. That's why I'm using this command. Let's cut this out. Okay, so we'll start with plotting something. So let's say I want to plot this function. So my function here is f of x equals sine x into cos x. Okay, I want to plot this function. So to plot a function y, I need the range of values of x. So I can generate the range of values. So if you remember the last tutorial where we discussed about this particular function called np.arrange. You can give the xmin, xmax, and the delta x value. It will arrange your x, the x values. So this is for arranging the x, ranging from x min to x max for the given delta x value. Okay, so first I'll take some x min. So if you remember, this is how we get an input from the user. Let me just give it as, so since I'm working with okay, let me just give first 0 for me. And you just need to do this because it always takes it as a character, so I need to convert. Oh, I didn't run this. Let's run this first. So first I need to import the libraries, then 0, and importing this is, let's say, some 100 x max. This is x. Okay. Now if you see x, this is my x value, so I can see delta x 0.1. That's why it started from 0, goes to 0.1, 0.2, it goes all the way till 99.9. remember, it doesn't touch your x max. So if you want exactly to be 100, then it's better you can give it to be plus, you can add a plus 0.1 here if you want it to exactly touch it 100. Okay, for now I don't want it. Just first of all run this. So this is the code to plot something. First of all, this command was just to display the file on my Jupyter notebook. Otherwise, you can just ignore this. This is a basic command called plt.figure. This is to invoke a lot of parameters of the figure. You'll come to some of the parameters later. First of all, this is one of the parameter in figure, which is called fig size, or the figure size. So changing the figure size will change the figure, the output's figure size. For example, if I keep it as 5 and 5, so it will give you a 5 cross 5 figure. It doesn't look that good, so I elongate my x-axis to something like this. I'll change my xmin and xmax to something of multiples of pi. So since it's a trigonometric function, I'll use some, let's say, so minus 2 times 10 pi, and so this is 2 times, okay, yeah, so this is what we get, sin x cos x, right. So this first line was just to sets up the figure size. Okay. And now these are the labels for the plot. So x label plt.x label will give you the x label, which is x in this case. So this is your x label, and this is your y label, which is y of x in this case. Yeah. Okay. And finally, this is your main uh, line of the code, which is plt.plot. As I said, plotting, to plot a function, you need this. The first argument specifies the x value which I need to plot. The second argument is the y value. So whenever I say x and y, it refers to this x and this y. So it plots each value one by one. So I'll just print them and show you. So if I print, let's say, x comma y, so you can see. Okay, I'll do one thing. So I'll just run and show this. So it takes this value. This is the first x value it will take, and this is the first y value it will take, and it will plot below. Similarly, keeps on looping for the whole x and y values and plot. So suppose if the x and y arrays are of not the same size, then it will result in an error. For example, let's try to do that and see what we get. So if I try to append value, let's append 10. Okay, I should use np.append. So a 10 is appended at the end of the thing. So now if I run the code, oh, I forgot to write that. So I'll write it again. Y equal to np dot open. Okay, gave you an error. So the error says that x and y must have same shape, but they have different size. Therefore, it cannot plot. Okay, so that's your error. Go back and rectify this. So yeah, I hope you understood. And the third parameter here is dash. So this means it's just a dash. If I change it to say 2 dash, you get something like this. So this is just to play with, you can play around with this markers of Matplotlib. To get the idea of the markers, you can go to Matplotlib documentation and search for it. You will be seeing it. It should be there somewhere. Mm, Go to modules, go to plot by plot, let's plot. Yeah, so this is a plot function. As you can see, these are all your markers here. Like this is the line style. So this is the solid line style. This is the dash line style. This is dash dot line style. Let me try that. Try that for a second. Yeah, so you get dash dot. You can change it to, let's say, just a dotted line with the colon. Okay, and this is your line width. So if I change this to, let's say, 10, so the width of the line changes. It's good to keep it low because it will look more attractive based on your data points basically. So if you have less number of data points, you can increase your line width and show. Okay, um, so this is it. So this is how you can play around with this if you want. And this is the line characters, but if you want, you can change it to some markers. For example, if I just put a dot, see, it's just a dot. It's not a line anymore. You can change it to all the different kinds of markers. You can go around and play with it. Okay, so this is a interesting. This is an interesting marker. Right. Now I'm moving on to another ways to make the plot attractive. I can use I can give a title to the plot. So plt dot title will give the title to the plot. So let me call this as plotting sine of x into into cos x. So you can see the title is here. What else can you do? You can change the x tick. For example, if you want more x ticks, you can more ticks on your x size. You can change that. You can change the scale. For example, you can change it to a log scale. You can change the log scale, or also you can put the grid. So you can put plt.grid, show the grid as well. Okay. Suppose I want to plot two functions together. Let's call this function y1, another function, let's say, what should we do? Let's plot np dot sine of x by x. There's another function which will plot now. So this is one function, this is another function. Just plot both of them together. Let's see what will happen. For the same x values I'm plotting. First of all, let me just run this. And then here I'll change the marker so that you can identify. Okay, I have plotted two functions together. One is a sync function and another. Okay, so I should change the title. Let's just do plotting two functions together. Right, so I have plotted two functions together on top of each other, and I differentiated them based on the markers. Suppose you are using the same marker, then how do I differentiate them? So you can use something called as the legends. To use the legend, you have to first of all specify the particular thing. Let's call this as sine of x, cos of x, and this as sync x. Okay. Then to invoke the legends, you can just call plt dot legends. Okay, I forgot to write this. We should write label. So we're labeling both the graphs. We should put the keyword label. Okay, where is it? There's some error. Oh, legends, legend. Right. So as you can see, for this marker, this is the thing, and this for this. And again, you can play around with the position of this. You can just check this out and see how to vary the position. Like you can keep it over here or there, and then you can change the font size. If you want a better font size, you can change that, and yeah, you can do a bunch of stuff with the Matplotlib. Okay. We can also invoke error bars. Like suppose you are doing an experiment and you got some errors, you can use that. For that, you can go to error bars and check. I'll just search and show you error bars. Yeah, like this. So you can plot the error bars. You can keep the error bars and show. That will also be helpful. And finally, since I'm using an interactive notebook, as you can see, when I move my cursor around this figure, it will show my x and y values here. See, and you can zoom. Let's say I want to analyze this position. You can zoom here and see. Suppose I want to I want to save the file. And okay, the grid's showing some. Okay, suppose I want to save the file. I can click here. It will save it. Where is it? I don't know where it. Okay, the best way to save the file is okay. I think yeah, but the best way to save the file is using the command save it. Yeah, let me just save them as to func.pdf. I'm saving them as a PDF file. So I saved it as a PDF file. If you go back to the directory where you're working with, you'll find your file. Okay, it's not being loaded in the. Um, yeah, yeah. As you can see, it's there in the directory, so it will be saved. Okay, so this is how you save your files. Right. So I'll move on. Now we'll discuss about the subplots. So this is plotting. So we were discussing plotting functions. Now I want to. What if I want to plot multiple functions in the form of subplots? For that, we can use Matplotlib again. So next section we'll be discussing plotting subplots. Right. So I'll again create two kinds of array with different delta x values. As you can see, one is dx is this one, and there is dx by 20, creating different x arrays. Okay, and I'm creating different functions. One is minus sin x cos x, minus sin x cos x square, and the one is e power minus x by 4 times sin x. Okay, now I'll just run this first of all. Now here, I'll first of all run this. So this particular thing, as you can see, it's a subplot. It's basically one figure, but there are two kind of plots in the same figure. It's called a subplot. This is the subplot one. This is the subplot two, and It's mostly used in whenever you want to compare a set of two figures together, like two different conditions. Whenever you are working on a problem where you want to analyze the figures in two set of conditions, then you use subplots. So to use subplots, first of all, you have to invoke the plt.figure argument, plt.figure code, which you used here, the same thing. You can change the figure size as well if you want. Let me put that as well. Okay. Then so this is the number of the figure. So this is basically the number of the figure. That will uh, so if I use another number, it was I am actually looking at another figure. Okay. So here this will create a subplot of of two rows. The first one is number of rows, one column. Okay, so it will create two rows and one column. This is the number of columns, number of rows, and this last command is your the plot figure. So here this is the figure one, the first figure I'm plotting, and this second guy is just two, again the two rows one column, because I'm specifying the same thing, but the second plot. Or I can call this as plot 2. Let's say this is plot 2, and that is my plot 1. Plot 1. Now I just plot them, plt.plot x1 comma y1 r, because so this will change the color. So if I change it to b, it will be black. K is, sorry, b is for blue, k is for black, and this line width, and then plt.show. Similarly here also, so and you get something like this. So if you're curious to see what will happen if I change this, no, sorry, I forgot to change it here. See, uh, this is now a 2 cross 2 file. So this is a 2 cross 2 file. Okay, and this is my plot 1, referring to this plot. This is my plot 2. Plot 3 and plot 4 are empty for now. Let's just change it. Let's just make some difference. So x1 is for this guy, x2 is for this plot. Let's just fix it like that. Now let's define y3. Let's just take an arbitrary function. Let's again, why don't we call exponential, let's say minus x square by 4. Okay, and then I'll call a y4, which I um, that would be something like log log x whatever. Okay, square. Sorry. Right. Um, Now I'll come back and just copy paste this for, okay, here. That's all. Okay, so now I'll do it for x1 comma y3, but this is my third plot now. Let's see what will happen. Okay, okay, I didn't different both. Oh, I'm sorry. I thought I was writing on latex. There is something wrong with log also. Let me just write some symbols, sin x. Again an issue. Where is the issue? X and y has the, so again we have encountered an issue with the plotting. So x1 comma y3, it's showing an error. Because my x was wrong, so we should have pointed it out. So this is x1 for me, whereas this is x2. Okay, now it's there. This is just a Gaussian plot. Finally, I'll plot my fourth plot. This is plot 3. Fourth plot. By the way, you can do it side by side, so it'll be helpful for you guys. This is the plot 4, and this is y4, and this is x2. What am I doing? What happened? Okay. Now here I'll just change some of the settings. For example, I'll make this to be black with K. Okay, it looks good. Let this be something like plus orange. No, there's nothing called orange. Okay, G. Oh, the thickness is too much. Let me reduce the thickness. So, okay. So, right. So I hope you understood the subplot thing. So now suppose you want to edit this further, let's say with the title and so on, you can go ahead and do that. Let's say plt dot title. Mm, my first four crows for sub. I should. Uh, this might create error. Okay. Let's leave the title for now. I'll tell you how to use that later because I want to create an object there. Again, you can save them using the plt.save option and you can proceed. Uh, Further options for subplot can again be seen in the documentation. Just go back, search subplots. This one. Okay, so this is the end rows and end columns. Um, so it basically returns two things whenever you are doing a subplot. Like whenever you write this plt dot thing, basically it returns two kind of things like fig and one ax. This is your figure and this is your axis. Okay, so you can use the axis to work with your titles. um, like let's say for example you are having one axis, so this is just one axis, so fig comma x, this will just give you one axis. But if you want multiple axis, so I'll show an example. For example, if I come back here, try to fig okay, just open a new thing. Now if I just print x, sorry, okay, so ax 0 0, right, it didn't run there. So if you want to modify it like that, you have to specify it like this. You have to give two arrays. So since this is for two plots, you can give two and then you can modify this. So you have to do this in case you want to write titles and stuffs like that. For now I don't want to do that. Just okay, right, we move on. Okay, this was just another example for the subplot, but we already mentioned that. Okay, so this is basics for plotting. I hope you guys go ahead and plot. I mean, play around with this. Like it's really fun. Just need to go to Matplotlib and do. You can go ahead and do this part which I didn't do, the subplots thing. You can go and try to uh, like you can give individual X label, individual Y labels, and then individual titles you can give. You can make it really nice, and finally you can just save it using plt.savefig. Okay. This is about the basics for plotting in Matplotlib. Suppose you want to plot from a given file which you already made. For example, this is a file of given to me by Vaibhavi. She took this from SDSS server. So this is a CSV file. I'll first of all open this file in my text editor and show you how it looks. It looks really messy, but it's kind of understandable. This is my table one. This particular row corresponds to the object ID. This is U. U refers to the magnitude in the using the filter U. I'll so if you are not understanding the theory of that, it's okay. But just consider this as a row. I'm sorry. This is a column U, and this is the column G, R, I, Z. Okay, and they all are separated by comma. That is why it's called a CSV file, comma separated value. Right. So now I want to load the file, and then I want to analyze them. Let's say I want to plot U versus G, or U minus G versus U, stuffs like that. Let's see how to plot that. Okay. To load the file, you can either use the NumPy module or you can use pandas, which I'll come to later. First of all, let's use NumPy, which you already studied, which is I imported it as NP. So there is a function called load txt. Is there a doubt? Is it separated by spaces? Yeah, you can still store it as CSV, but um, it's just an extension. .csv is just an extension. But if you want the file to be read in a proper way, you have to specify the something called as a delimiter, which is right over here. So if it's a CSV file, if I use comma to separate the columns, then I have to use comma here. Suppose if I use space, then I have to use space here. Okay. So it all depends here. This is just an extension, just to let the people know that the file contains comma separated values. Okay. So first of all, np.loadText is the function to load the thing, and this is first of all the file name. So this is a particular file name, and this is an interesting command called unpack. So what unpack does is that, so it will read each line by line and it will unpack the particular row. I'm sorry. Okay, so it will unpack the rows. So when I use unpack equal to true, it will just take the first row and then unpack the row and store it in the given variables which I declared on the left hand side. Okay, that is the argument unpack. Then the third argument, skip rows, will skip the unwanted rows because I don't want them because they don't contain the data. There are two rows here which I want to skip. This of no use to me. So I use the skip rows to skip them. Use columns. So this will specify the columns which I want. Here I am plotting U and I want just U and G. So this is my column 0. Object ID is the column 0. Column 1 is U, column 2 is G. Okay, so I'll just take column 1 and column 2. So this is use calls 1 and 2. And finally, the thing that separates column 1 and column 2 is a comma. Therefore, that's my delimiter. Okay, I hope this is understandable. Just run this. Right, so I what unpack does is that, so it basically takes the first column, column 1 and column 2, unpack them. So that's all, and I can just simply plot it using this command. Tada, it plotted. Um, some couple of stuffs which you can do, like so there's a new thing, if you recognize that, it's a marker size. If I change the marker size, you can see how it looks. So if you can change the marker size if you have more plots, like here it's a bit scattered. So in that case, I can change my marker size to, let's say, some 0.1 or something. 0.1 is too much. It's 0.6. Yeah, so you can change as per you wish. And again, I can put uh, plt.figure size, just the same way we were doing here. I think this looks better if it's a square plot, I guess. No, it doesn't. I'll come back and rectify that. Plot this as 5. time comma. Right. Still okay. This is fine. Now my labels like X label. So I'm plotting u minus g on the x-axis. Don't worry about the why am I plotting u minus g and all. It's just so this is something called as a color magnitude diagram. I'll just this is a color magnitude diagram. So this is my x level. My y level will be just and then I can just uh, I can also put the title. Say plt.title. So this is cmd of cluster. Right. So yeah. Grid on a grid you can do that. You dot say fix cmd dot pdf. It looks really good. Okay, this is how we. Now suppose if you want to plot it in a much more organized fashion, you can use pandas. Pandas again you can use in paper. Um, just go object which will be dealing with called data frame. Um, so I'm using this function called read CSV in pandas, which will read the CSV files. So I'm reading the file and I'm just skipping one row. So when I skip just one row, automatically the second row becomes my column name. So these are my column names. So if I use the data frame dot head function to show the first few datas. So this is my first column. So if you want to invoke a particular column, just go ahead, call the object, data frame object, which is data frame here. If I do object ID,
I think you stopped
we call the
presenting.
object.
It's not.
Yeah. I'm sorry, what?
The screen is
Oh,
not visible.
my
You
screen
like
went off.
the
One second.
another account.
One second. Can you see my screen now?
Yes. Yes.
Yeah. So where did that happen? Like, can you can someone say where did the screen went off? Like at what portion so that I can repeat?
Pandas only.
Okay. Okay. Right when I started Panda. So it's fine. So I was discussing CSV file. It will take a CSV file. It will skip a row, and then it will show the header files. This is to show the header files, and the data frame object ID file plot. It will show all the object ID. Right now, if I want to see, let's say the second row, the U row, I can just use data frame U. Okay, and if you want to see the whole columns, you can just write data frame columns. So these are my columns. Okay, and these are useless if by default it's useless. I want to convert it into numpy arrays so that I can plot it and so on. To do that, I have a built-in function called toNumpy. So just invoke data frame u, and then say dot to numpy, so it will automatically become a numpy array. So if you just write u equal to data frame u dot numpy, so it will automatically become a numpy array. So if you see type of u, so it shows that it's a numpy array, right? So I can do the same thing for all the columns. I'll do it for G. I'll do it for I and Z. I'll just keep R for now. Okay. So I took everything in the numpy arrays. Now I can just plot them. Plt.plot. Let's say I'm plotting u minus g versus u, which I already plotted. Oh, sorry, I forgot to invert this. I should have stopped it. Every time, if you're not stopping it, it just plots one over the other. It's really messy. Uh, okay. See, it's really irregular because this by default, Matplotlib will plot lines. You have to convert it into markers, whatever you want. So I'm using red marker. Again, it looks really awkward because of the marker size. I change it to some 0.5 or something. Right now, I'll also plot. Um, why don't we try this? Let's try to plot a subplot. Come back here. Plot the subplots. Right. So one plot will be u minus g versus u. Another plot will be um, let's say I minus z versus I, and the size is some 0.5. Do the same thing. Let's let's make this r dot and change it to markers. Change the markers. Okay, I don't think we need markers. No, you didn't markers. Marker size. Yeah. Yeah. So yeah, now you got a subplot. You can compare both the things. Just change this. You can compare both, and you can also again you can change the titles and so on. Okay, so this is how you use pandas and get it. So you take it using read it using read CSV. So I forgot to mention the other kind of other functions for reading. So data frame equals pd dot. If I just press tab. So these are the other functions. Let's say read Excel. It will open a dot Excel uh, SX file, and this will open JSON file. Yeah, this SQL table and so on. Okay, there are a lot of functions for pandas. Now, finally, how to write something. So to write something, you can use np.save text. So suppose I have x values and some y values, y equal to x square. I can just save it as in save text in sample file.txt x comma y. Okay, so this will save the it, x and y's in the file sample file.txt. Then I can again load them in xi, and you will be able to load it like this. Okay, so yeah, you can just save text to save it. Finally, I'll just take 5 minutes to explain this. If you're interested in doing animation, then Matplotlib offers a library called animation matplotlib.animation, import it using something calling it as anime. Um, Again, use Matplotlib notebook if you want to display it on the notebook. Um, First of all, to do this, you need to use the function called function animation object, which is the figure object, which is this guy, which we have been declaring earlier. So initially your x data and y data is blank. Okay, so initial x data and y data is blank. So you use this object. This object will be plotting the initial data, which is basically blank in this case. And then this particular function init, this will be initializing the sets. So my initializing conditions will be setting the x limit to 0 to 2 pi, which is here, and setting the y limit from -1 to 1. Okay, and then it will return the same object. Keep in mind, use the same object here, right? And then so that will go here. So this is the initialization function uh, argument, and then this particular argument is for the argument updating the particular function, is called the update. So you go to updates, and here you have to pass the frames which you can initialize it. Here I am going from 0 to 2 pi for 128 frames, and then pass each frame. So let's say you take a frame called, your initial frame will be 0. So you go to 0, x data will append the value 0, y data will append the value sine of 0, which is 0. Then ln, which is my object which I declare here, if I do ln dot set data, it will set the data to 0 comma 0, which is this guy, and then it will return ln. So my animation, any func animation will show that over here. Okay, then it will loop, go to the second plot, which second frame, which is the value, which is, so basically it will divide the 2 pi thing into 128 frames. So basically 2 pi divided by 128, that will be the next value of the frame. So it will again go to the update, and x data will append to that value. I'll just print x data and show you what it contains. So yeah, second value is some 0.049. So it will go to 0.049 will be updated, and the corresponding sign value will be updated, and the object ln will set the value, which is this guy, and then it will keep on doing it. Okay, and again you can do your normal editing, like you can change the marker size. I'm sorry, you can change the marker size if you want, and yeah, you can notice how it works. So each frame by frame, it it goes to the update function, changes it, and comes back. So this is the best way to plot animation. So whenever you want to plot a function um, animation, let's say you want to see how an orbit evolves over some time, you can take your x coordinate value, your y coordinate value, your time will be changing. That will be like your frame in this case. You can change the time values and you can work with it. Okay, so this is your animation. Finally, you can save your animation just like how you save your normal file, which is which is animation dot save. Can save it as an animation mp4. I think I should use some encoder, which I forgot. I hope it saves. So there is if you just search for that, you might get it. Let's just search for it. Go to Matplotlib documentation, search for animation. Is there anywhere this saved? Okay, let's just see this. Um, okay, you can search for it. You'll be getting it. Okay. So yeah, that's how you deal with animation, and I think you can also save it from here. You can download the plot. I'm not sure why is it not working, but yeah, you can go ahead and do that. Okay. So yeah, this was the second part of the tutorial where we discussed about plotting the functions in Matplotlib, as the subplots, getting the opening a file and then plotting whatever is there in the file